Yeah, no problem. Wonderful to meet y'all. Thanks for joining. I'm Phil. I'm head of sales at CAD Active. I have a couple of my teammates on the line with me as well today. And we're here to talk about piping design in Creo Parametric. And you guys can see my screen, right? Can you see the PowerPoint?
Yes, it's showing up, Phil.
Okay.
Yes.
Cool. Awesome. I think I may have met some of you all, or we may have met some of you all at the user group event in Orlando last month. But if we didn't, very nice to meet you. So again, we're talking about piping in Creo Parametric today. I'm going to fly through some quick intro content and kind of set the stage for a Creo piping discussion. And then from there, we're going to jump into a more interactive technical demonstration in Creo itself. So please feel free to stop me if you guys have questions. I'm happy to make it as interactive as possible. So I guess first, just a quick introduction to CAD Active. We're a PTC technology partner. We focus on Creo Parametric specifically. We all know that Creo is a powerful and robust CAD tool, but it's not always the easiest to use. So we build automation applications inside of Creo to help increase efficiency, power, accuracy, usability, typically for Creo's more complex processes. And piping design is certainly one of that. So we help our customers with a combination of Creo-based software, applications, and professional services. And we've worked with customers all over the world, which means that we've seen all kinds of different challenges, and our platform's kind of continually evolving. Just to quickly highlight a few topics that we typically tend to focus on. Task automation, right, is one of them, cutting back on click-heavy, error-prone nature of Creo. Model performance, ensuring that models are accessible, lightweight, and make sure that they're usable. Data connectivity, making sure that the data is flowing through the entire process automatically every time. Oftentimes that means integrating non-native systems into Creo, which we've done with several non-PTC tools, specifically on the ECAD side. And then data fidelity, we not only help kind of improve efficiency, but help you design the right way, follow the best practices, make sure that accurate and complete data is included in every model early and often. Cool. So let's get into piping design in Creo. So to start, I just wanted to give a really high-level overview of the different options that are available for piping design in Creo. And when I say piping, I could mean rigid pipe, flexible tube, HVAC, waveguide, really anything that you route. But across, I guess, all of those, there's really three ways to route pipes in Creo. Number three, sweeps and extrudes. Number two, using the piping module, the piping and cabling extension. And number one, spec-driven piping, which is really what we're here to talk about today. I was going to maybe pose a question and see if anybody, is anybody on the call using spec-driven piping today in practice? Maybe like raise your hand if you are, or feel free to speak up. Typically, it's a pretty small percentage of folks. See anyone speaking up, and that's pretty typical. So I guess we'll just jump into to quickly tell you the three different types of piping. Number one, you can build pipelines using Creo's core modeling functions. Make a circle, extrude it out. This is like Lego building, you know. And you know, if you're doing any substantial piping design, I hope that you're not doing this. I don't envy you if you are. There's no real data reuse here, standard components. Anytime you want to make a change to a pipeline that you've built, you're really having to rebuild that whole thing from scratch. So we're not going to linger on this one too long. But most folks that we talk to today are using the core piping extension in Creo to build piping designs. This leverages the standard components library. It has some intuitive tools for routing, right? Extend, segment, connect, You have the ability to place components in a pipeline. That's nice. However, placing fittings specifically requires manually combing through an entire library, which can be error prone. Pipelines are still relatively inflexible, and design changes require a lot of rework. And there's no option for automatically leveraging a P&ID or any logical data in Creo. So we find a lot of companies are manually translating, P&ID concept data over, like either doing a PDF or printing it out and kind of going component by component into Creo. So that brings us to spec-driven piping, which is kind of the latest and greatest piping module in Creo. And it's included with the core piping extension, so you don't have to pay anything extra for it. And it really allows us to embed intelligence into the library parts so that fittings and pipeline components are related and associative with one another. So this gives us the opportunity to vastly simplify user interface and optimize usability. Arguably more importantly, spec piping makes change management way easier. More of this flexible drag and drop style of piping design. And probably the biggest one to highlight is that it does allow for the import of logical P&ID data. So, like I said, right, 3 main reasons why spec piping is superior. Associativity between your standard components, simplified pick lists and user interfaces, change management becomes immensely easier, and we can use schematic information in Creo specifically. So what's that mean for kind of the process as a whole? This is what we see a lot of our customers doing today and how they design piping systems in Creo today. You may or may not have intelligence in your P&ID tool, in that you have metadata associated with the different components and pipes and fittings. But regardless, you're probably manually extracting key information and plugging it into Creo, either by just printing it out or putting the diagram side by side, but it's component by component. So similarly, in order to place a component, you got to comb through your entire library of parts in order to do that, which can be tedious and error prone, right? Similarly, without spec piping, there's no native pipe rule check functions or ways to automatically ensure that the 3D model matches the concept drawing or the P&ID at all. Right, so we like to show these diagrams because they kind of give a good comparison from kind of the current state to the future state, right? So we see, a lot of manual translation, a lot of selecting things by hand and getting them in there, right? Once we have spec-driven piping implemented, it allows us to kind of automate a lot of those handoffs, right? So spec-driven piping enables schematic-driven piping. And what I mean by that is that we can automatically extract data from a 2D concept design tool. Natively, Creo supports Creo schematics, but we've worked with other customers to help integrate other ECAD tools or P&ID design tools so that Creo can digest that information. So not only is it easier from a usability perspective, but it makes sure that we're doing this accurately and that the right data is getting through every single time into Creo, right? And then finally, just a couple additional benefits that are kind of offered with spec-driven piping on top of what I just spoke about. We can run pipe check rules in spec piping to ensure that there's no bend violations or size mismatches or missing components. It also unlocks some additional reporting capabilities like a pipe roll up or a fitting bill of materials or schematic checking, going to make sure that, hey, maybe the schematic information changed. We need to make sure that those changes propagated through to Creo. So let's go check against the P&ID to make sure that our piping system is complete. On the manufacturing deliverable side, isometric drawings become infinitely more achievable with spec-driven piping. M4 ISO is the industry standard for creating isometrics. They're a third-party company. They're based out of the UK. We've worked very closely with them to help implement that system and help customers kind of set that up. But yeah, just a couple additional pieces of value that come from spec-driven piping. So the kind of golden question here is why, if spec-driven piping is included with Creo, with every license of Creo, why doesn't everybody do it, and why doesn't everyone use it? And when I asked at the beginning of the call if anybody used it today, and we didn't really have anyone put their hand up, right? Why is that? So the answer is because spec piping is difficult to set up, and it's difficult to deploy, and it's difficult to maintain. It's driven with backend text files that can be super complex, super finicky. There's a big learning curve associated with administering spec-driven piping. Editing, maintaining that library natively means that you're manually working with these text files, and you put a wrong space or a wrong tab or a wrong character in one place and the whole thing breaks. And so oftentimes these barriers deflect engineering teams from ever getting to the point where they can use spec piping. And so here's where CAD Active, our company, comes in as a PTC partner. We help build tools that make spec-driven piping easier. We offer easy and intuitive ways to kind of manage, maintain, edit, deploy that spec piping environment, both through a web interface that drives that library and pushes it into the Creo instance specifically, as well as with some tools and buttons in Creo itself that allow an easier way to manage an evolving library. So that's kind of what Ben, my colleague, is going to walk through today in Creo specifically. We're going to go and show some of the cool shiny features in the spec-driven piping module itself, kind of show you what I'm talking about. So yeah, I think maybe with that, I think that's all that I had. Yep. Yeah, I guess before I pass the ball over to Ben, I'll just say whether or not you guys are looking for, automation or just help in Creo specifically, we want to be a resource for you. So if you like what you hear, we'd love to have a conversation. Please don't hesitate to reach out to us directly.
Phil,
yes,
question.
hello.
On the spec, I'm getting the impression is that essentially you provide a schematic of what the piping route should be. Is that what's meant by spec?
Yeah, so,
well, go ahead.
I can jump in here. This will be a part of what I'm planning to demonstrate, but there is, so Phil had listed those 3 different options, and not listed on there was schematic driven piping, which the reason it's not on there is because it's not technically a different way of routing. It's just kind of something that the door is opened up to you once you have spec driven piping implemented. That bringing information in from a schematic and using it to route your pipes inside of Creo Parametric is not possible unless you have spec-driven piping implemented.
Okay.
Yeah, and obviously processes at different companies are different. But a lot of folks that we run into kind of build these P&ID process and instrumentation diagrams up front to kind of determine what equipment and what components are going to need to be included in a model. What that doesn't include is routing information, bend radius information, additional information that you might need to gain from having this complete 3D representation of your model. So yeah, I think we want to make sure that that concept data makes its way into Creo regardless of what P&ID tool you might be using. that answer your question?
Yes. Thank you very much.
Cool. All right. Well, Ben, you want to show them some stuff in Creo?
Sure do.
All right. I'm going to stop sharing. Let me know if you have any issues sharing.
All right.
Got it.
I'm gonna go ahead and drag that bar over to my other screen so it doesn't get in the way of me here. So here we just have a kind of a general layout of some piping equipment in a little fake room here. I think I'm actually gonna turn that off so that we can see this a little bit better. But essentially, I'm gonna run through all the three different, well, not all three, but I'll run through non-spec driven piping, just using, the piping extension, then spec driven piping, and then I'll show schematic driven piping at the end. So first things first, we're going to go into the piping application. There's a checkbox here in the corner for spec driven. This can be controlled with a config setting. So there's basically three different options. You can either force spec driven to be used all the time or never. And then in either of those scenarios, this checkbox is gray and unselectable. Or the third option is leaving it up to the individual user's discretion which they want to use, and that's when you actually have the ability to turn this on and off. But first things first, I'm going to start with it off, and I'm going to create a pipe in non-spec driven piping. So I'm going to give that pipeline a name of non-spec driven piping, and then it's going to ask for a line stock as well. So this is what non-spec driven looks like. It's going to pull up this interface here where it allows you to define your pipe line stock. So you can have line stocks saved that your users are using, but they're going to need to manually type those names in where I just typed in this non-SDP name. Inside of this interface, this is where you can define whether you've got a rectangular or a circular section, whether it's solid, hollow. You can define those different dimensions, and then choose some other things like straight or flexible. What are you using for the corner types? Is it allowable for this pipe to be bent, or does it have to have an elbow at those corners or some type of fitting? You can also define some of the different properties of the pipe down here. There's also a design rule tab. This allows you to set up some design rules. But it allows you to govern, what's the maximum overall length of this pipe? What about the segment length? Bend angles and radii, all these sorts of things you can set up in this table. And then you can add some user-defined parameters here as well. But really the difference between non-spec driven and spec driven piping is all of this definition is already done for you in spec-driven piping, and there are rules that your users have to follow, and they're given pre-populated pick lists, and they're not allowed to make place a fitting that actually should not be allowable in that line, which will also be a part of this demonstration. So as I go and hit OK, now we can see we have our pipeline and our line stock in the model tree. Next thing we want to do is go ahead and set our start. So I'm going to choose this coordinate system here on the S3 port of this panel. I can say OK, and then we have a bunch of different ways that we can actually go and route this pipe. And that's what I'm showing here is not anything that's different between spec driven or non-spec driven piping. This is going to be consistent across the board. So you can really just drag that, extend however you want. If we wanted to, we could type in a dimension here. I'm fine for now. I'm just going to say OK. And I just really want to quickly show what it looks like to insert a fitting when you're in non-spec driven piping. So you get a little menu manager here on the side. There's a few different options here. Your end is going to be, like your caps. Corners are going to be elbows. Straight break are going to be a whole bunch of different types of fittings like reducers or T's, things of that nature that are going to be in line with the pipeline and create a break in that pipeline. There's also straight continuous. So this is the final type. It's something that's a straight inline fitting on the pipeline, but it's not actually going to create a break on that pipeline. So these are things that are, a good example of that would be maybe a U-bolt or some sort of support that's going to be placed on the pipeline, but it's not actually breaking it. You can still place those fittings as a part of the pipeline in the model tree. I'm going to choose a straight break, and I'll navigate to my piping library, fitting library. I'm going to grab a straight branch. Let's do that. So I'm going to grab one of these bigger sizes. And once I hit open, now the only thing left to do is to determine where on this pipeline I want my fitting to be placed. So I'm just going to grab a point here and give that the actual length. There's a few different options there for how this can be placed, but it's, nothing too exciting going on there. The next thing that I need to do is provide a point on the fitting that's going to be used to be placed at the point that we've just created on the pipeline. So you can see that pop into place, and I'm just going to go ahead and hit done. Now that allowed me to place this fitting in the pipeline, but you can very clearly see that's not going to work. That doesn't make any sense. In this scenario, it's obviously it's super obvious that that is not the correct fitting that should be placed there. But you can get into scenarios of, maybe you're one size off or something, and the fact that it's not actually lining up is not going to be nearly as clear visually. Or maybe it's just a simple matter of you've chosen the wrong schedule, and it does actually line up perfectly. It's just the thickness of the pipe wall is different. So this is kind of the drawback to non-spec driven piping, is the fact that you're allowed to make these mistakes, and also inserting fittings is not as nice and easy of a process as it is with spec driven piping. So that is kind of the conclusion of the non-spec driven portion. I'm just going to go ahead and delete that pipeline, get it out of there. Then we can go back into piping, and I'm going to start with a spec-driven pipe now. So same exact button, that create pipe button, but this time, now that we have the spec-driven checkbox checked, I can click that button. It pulls up a whole different, a little bit prettier interface here. So on the third portion of this, whenever I'm showing a schematic-driven pipeline, I am going to use this portion up here. This is kind of the same as the spec driven. You can have a config setting to make sure that this is either turned on or off by default. But right now I'm going to turn that off. And well, hang on now. Oh, you know what? I actually have changed some of my settings here. So I'm going to take this off screen real quickly. Basically, there are config settings that drive where you're looking for your spec-driven catalog. And I have switched it away from the PTC default, which I need to switch it back to right now. Just give me 1 second to navigate to it. Actually, you know what? This is probably a good thing to show. So as a part of the Creo install, as Phil had mentioned, spec-driven piping it's just default out of the box available to you with every license of Creo Parametric. And to prove that here, inside of my Creo 705 installation in the common files folder, I can go into text, and in here we have this piping data folder. And for now, I'll go ahead and click into it. But this should be everybody on the call that has Creo Parametric installed, you should have access to this. And it's just kind of a default out of the box, simple little library for spec-driven piping, not going to be configured for what a company would typically want to have if they were going to be using real piping in their designs, but good enough for testing this out and trying it and seeing if you like it. But what I'm showing here is a CAD active tool that allows me to change all of these different config settings where I'm looking for my piping catalog with just that, this one button. I can go navigate to it, grab it, and it's going to update. It's even more than just these few settings. You see 4 of them here. I think there's really like 7 or 8 that drive where Creo's looking for certain things. But now that I've done that, yep, there we go. Now we're seeing what I was expecting to see populate in here. So now if I deselect that schematic driven checkbox, we have a drop-down list for all of the different specs that are available to us. We can see for the MS spec that I have set up here, we have sizes 10A to 250A. This is in schedule 40. There's no other options there for this particular spec. And also there's no insulation by default. If I change to this HA specification, you can see we get a completely different list, or I guess not completely different, but more inclusive list from 10A all the way to 500A. And now the schedule selection that we have is schedule 80. And again, there is an insulation type by default. We have a different mnemonic. Basically, all of this is part of the intelligence that we have pre-populated into these specs. And this is all being driven by those backend text files. So I'm going to create a spec MS size 40A schedule 40 pipe. And now, as I had mentioned before, the actual routing of the pipe is kind of the same either way. So I'm going to do the same process and select my start point. The difference here is that now we see there's a few more options here. So even though we've chosen that the combination of spec, size, and schedule, you can still change it here on the fly as you go to route the pipe. Similarly, we can use this extend. I'm going to just choose a couple of dimensions here. Let's go ahead and apply that. Just route this thing around. So what you'll notice is as I make that change in direction of the pipe, this pipe that we have set up, the MS pipe, is bending rather than I guess this pipe is bending because we have bend rules set up and defined in our Spec-Driven database. If that was not the case, if we did not have these bend rules set up, then at each of these corners that are created by the pipe, it would really just kind of run one pipe all the way up to that corner and then become disjointed and have the other pipe run from that corner up to the next dimension. And then from that point, there's actually some really easy ways to just say, I want to replace every corner with an elbow fitting, and it'll go snap into place. Every single 90 degree will be populated with a 90 degree elbow. If it's, maybe it's a 45 degree, you can choose to have that filled automatically with a 45 degree elbow as well. That's something that a lot of people will do if they're not going to be bending their pipes. They'll kind of route the whole pipe using just the center lines. And then once they're done with the design, just choose to, in one fell swoop, go and replace all of those corners with elbow fittings all at once. So besides just doing those extends, another piece of functionality here, we can use this connect button. And if I do that, it's going to ask me for 2 inputs. So I'm going to choose the end of this pipeline and this port coordinate system. And then it's just going to create a connection between those 2 points. Now you have these drag handles that I can move this around. Once it goes to a point where it's violating the minimum bend radius, you can see the routing disappears. If I bring it back to where, okay, we're within that allowable bend radius again, the representation of that pipe comes back. And then again, you can either do, those drag handles, or you can give an actual dimension here. We can see that update the straight section coming out of this port. So now we've got a pipe routed. And what I want to show off is what it looks like when we go and insert fittings with spec-driven piping. So same button again, going to be a completely different interface. Now this is the spec-driven piping insert fitting database, or not database, but interface. And I can just pick a point anywhere on this pipeline. And all of the different types of fittings that I have in my spec-driven database are going to be showing up down here. So they can be organized into these different categories. This is all customizable, what you want to show up where. If you want to have fewer or more of these icons, totally allowable. If you want to bring in your own image files, something that makes more sense to you, you can do that as well. But basically, once I select one of these icons, it's going to have a list of all the different options that I have. So this icon for me signifies flanges. I have two different types of flanges here that are available. I'm going to pick a slip flange. There's a couple of pieces here that I want to point out after I place the fitting. And I'll go ahead and expand that so we can see what all is included in this subassembly. First, there's this bolt nut code, and then there's a checkbox here for automatic flange and gasket. So first things first, I'll go to my placement and orientation tab. This is going to show me what that fitting is going to look like. We can see that this is actually backwards of the way that I would want it, and of course not in the position that I would want it, but I can simply hit the end button. Because it's a flange, Spec-Driven knows based on the port 0 and port 1 locations what way this flange should be oriented if it's on the end of a pipe. So when I hit that end button, it not only moved it to the end of this pipe segment, but also flipped it around so that it actually is oriented the way that makes sense, right? And then if I go ahead and hit apply, we'll notice that not only did it place the flange, it also placed a gasket in there as well and created this bolt nut bulk part. So for anybody on the call who's not aware, bulk parts are, they're a way within Creo to place a non-graphical representation of a part. So in this scenario, we know that we're going to have 4 bolt stacks here with whatever combination of size and length of bolt, whether we have a washer on both sides, a lock washer, nut, whatever that stack looks like, we can program that into this implementation of spec-driven piping as well. And whenever we place our flanges, that's going to create a bulk part in the model tree that now we don't have to have a graphical representation of those parts. That in a really large assembly, if you have detailed threads on your bolts, that's really going to drag down your model performance. We don't have to actually represent those graphically. We can use this bulk part, and the information about what is included there is going to be stored as parameters on this bulk part. So when you go to get your bill of materials, all of that information is going to show up still based on being stored in this bulk item in the parameters there. So that's one thing. That was the first drop down there. The other thing was the checkbox for automatic flange and gasket, and that is the way that we set up the rules for how the flanges and gaskets should be paired and assembled together. So you can see there's my gasket here that was installed with this flange, and I can actually show another little piece of this functionality. If I just place one in the middle of the pipeline here, kind of the way that I had it set up to begin with, if I say apply, it's not only going to place the flange and the gasket, but also a matching flange on the other side to kind of complete that stack, right? So that's some of the functionality in terms of flange and gasket and bolt nut codes. We can also place a couple different fittings here. I'm going to go ahead and place a gate valve. So we can see it comes in with a particular orientation. We have a little drag wheel here that we can give whatever rotation we want. We can type in a number. There's also these preset rotations that we can use as well. So I'm going to hit apply. Let's see. There's a couple more fittings that I want to put in here. We got branches here. We have it organized so that the straight tees and reducing tees are all under one selection name. You can segment those out as much as you want. But right now, I'm just going to choose a size 15A, and we can look at that preview, or we don't have to. I'm just going to go ahead and hit apply. So these are all, actually, yeah, everything that I've placed so far would be under the straight break I guess, category of fittings that we were looking at earlier. The next thing that I want to show is one of those straight continuous fittings. So this is your clip, your U-bolt, your channel, all those sorts of things. And if I go ahead and apply, we can look at the way that this actually gets applied to the model. There's no break in the pipeline like what we see here at the interface between the pipeline and the branch. The fitting is just completely placed around the pipeline without breaking it. So you can, have any sort of different support or whatever you need, you can do that way. So another thing that we can do here is, this is one of the huge benefits of spec-driven piping that I'm about to show off. We're going to place a reducer in line here. And if we look, that's not the direction I want this guy. I can go ahead and just click flip, no problem. It flips around. And the really neat thing, let me turn this off so that we can see this very clearly. Once I go ahead and hit apply on this reducer, pay attention to what happens to all these downstream fittings and the pipeline. So we can see that with spec-driven piping, because of the way that all of these are used and driven from those backend text files, once we put a reducer in there, it's automatically going to update the downstream pipeline to the correct size and schedule based on what we've chosen as our reducer here. And not only that, but it's going to look at each of these different fittings that are downstream as well and change that from the selection that it made based on, or the model selection that was made based on the size and schedule of the pipeline when we first placed them, to what that selection would be now that we've updated the size and schedule of that pipeline. And you don't have to do anything. It just snaps all that into place for you. So if we wanted to bring this back up to the correct size, we could just place a reducer in here that brings all that right back to the right size. So the last thing that I want to show about spec-driven before moving on to schematic-driven piping is what happens when we come in and create another pipeline off of this branch. So one way that you could do this, if you wanted this all to be in one subassembly, your steam.0 in this case, or steam_0, we would say route pipe and then just set a start right on that coordinate system for the branch. However, I'm going to do it a little bit differently just to show off some of the other functionality of spec-driven piping a little bit better. I'm going to create a whole separate pipe. And this time I'm going to choose a size like 100A, obviously not correct for what should be placed on this branch. I'm going to have to change my pipeline assembly name to steam_1. But there we go. So MS 100A40. I'm going to say, okay, it's creating a new subassembly here for steam_1. But when I go to hit my set start, we see those same options, exactly what I just selected. When I choose the coordinate system for port 2, it no longer allows me to make the incorrect decision or incorrect pipeline size or schedule, whatever it may be. It knows based on a couple of parameters on that port 2 coordinate system, it knows what spec, size, and schedule are supposed to be paired with that or routed away from that coordinate system, and it won't allow you to do the wrong thing. So you can see these are obviously unselectable. I can say okay, and once I go to extend here, we see it is not that 100A size, but it is in fact the correct 15A size that should have been routed away from that branch. So that is kind of the conclusion of the spec-driven portion of the demo. Are there any questions before I move on to the schematic-driven side of this?
I had just one question, Ben.
Yeah, of course.
On sharing your screen, I noticed on the lower left corner, I guess you can see the tree or just the full screen just below your cursor down a little bit. Yeah, right there. Does one of those maximize the screen?
The Creo parametric screen?
I mean, your Zoom screen, as far as, because otherwise, I mean, I got black borders, I guess. I don't know if my screen isn't maximized.
Oh, I don't know if there's a way. I think that's more so just like the dimensions of my screen not lining up exactly with the Zoom window.
Okay.
I don't think there's a way to zoom in on Zoom. I think some other types of meeting software allow that, but I don't think Zoom is one of them.
So on mine, on the top right-hand corner, there's a view button that you can click and say enter full screen. I don't know if you did that already.
Oh, let's see here.
Yeah, this is Deb. I didn't do anything with that button, but mine is showing about 90% of my screen being with your window. So it seems fine here.
I've got the bottom. Oops. I've got maximum screen. I guess I'm able to zoom in and I got the black borders. It's not stretching, I guess, but okay. Well,
All right. Anything else before moving on to the schematic side of this? All right. So first things first, before I come back and route the pipeline that I'm going to get from my schematic, I'm just going to pop open the schematic that we're getting the import from. So here is, basically we tried to make this as close to the 3D representation as possible so that it's very clear. But this is that same design, but in a PNID. So these are all separate pipelines. The one that I'm going to recreate using this import is right down here, and I'm going to need to select that parent. So you can see I'm grabbing this entire pipeline once I select that parent there. And there's a few different properties here that I want to call attention to. First off, we have this full name of this pipeline is L6. We have the pipe number of 06. Again, we have our spec MS, our size 40, and our schedule 40A, and then our schedule 40. And we also have a mnemonic of steam. Besides that, just looking at the pipeline in general, we are coming from this 4-port panel, the S1 port. We have a size 40A pipeline coming out of that. We have a few different fittings here. We have a branch that's going to branch off, and it's going to be a reducing branch to a size 32A segment of pipe that goes to this double pump. Then we have a reducer that's going to bring that size from 40A up to 50A, a gate valve, and finally terminate the pipeline at size 50A at this red tank.
I got a quick question.
Yeah, of course.
Is this version of schematic what's included with our normal licenses, or is this an additional license?
So the normal Creo parametric license gives you a Creo Schematics Lite license, which that is going to allow you to open up Creo Schematics, play around with the PTC example catalog. You can do some catalog creation of artifacts. There are a lot of limitations to the Lite license, however. There's a limit to the number of sheets you can have in a design. There's under this design tab, you can see these 3 buttons are selectable. I have a central catalog that I'm pulling from. So in an organization, you would typically want to have one central catalog that everybody's working with the same objects. That functionality is not available with the Lite license. So you would only be able to have an internal catalog to the design you're working on. Basically, in short, the Lite license of Creo, the Creo Schematics that comes with your Creo parametric license, is enough for you to click around and get the feel of Creo Schematics, but certainly not enough to be able to use it in a real, true production environment.
And it's mainly because of that catalog?
That's a big part of it. There are some other limitations, but the catalog is really one of the biggest, I guess, gates to being able to use it for like real designs, I would say.
Okay, thanks.
Yeah. All right, so scooting back over to the parametric side of things. Now, to create that pipeline, once again, we're going to kind of work through the same workflow, but just slight differences. We're going to hit that create pipe button. This time we're going to leave this checkbox checked. And I'm going to browse for, I've already exported the XML file from Creo schematics, but this is just, exactly what I just showed. This is the export from it. I'm going to select that export, and immediately we can see we've populated the schematic label, is what they're calling it here, with all of the different options coming from that XML file. So specifically, the one that we were looking at is this L6 pipeline. So I'll select that, and we can see everything that I just looked at, all those properties have flowed in here. Spec, MS, size 40A, schedule 40. Our mnemonic is Steam. Our number is 06. And then that creates a subassembly of Steam_0-06 for us. So the difference here, instead of just hitting OK, because we're doing schematic driven piping, we need to first designate the components that we're going to be using. And it looks like I was away from Creo for too long. It's going to have to grab my floating license again. So we'll just give it a second to do that. But basically, I don't know how familiar people are with designations, but essentially, if you're bringing in this logical data, there are, just right here, we have 3 different models for this double pump. It's all the same model. So it has the same name in the model tree, which I can show here. 3 different double pump PRTs. So the real thing here is, how does Creo know which one I'm specifically talking about? And that's where we're telling it right now by designating this component as specifically not just the 4-port panel, but the 4-port panel 1 that we're specifically talking about. So it knows because of some, I guess I should have showed this on the schematic side, but there are parameters on each of those items inside of schematics that say what the model name is supposed to be. So in this case, for 4-port panel 1, in the schematic design, there's a parameter that says model name, and it tells it that the model name is supposed to be 4_port_panel. And because of that, Creo knows if I hover over any of these other models, it's not going to show those highlighting. Only whenever I highlight over a model with the correct name is it going to highlight, and I can make that selection. So now we can see that a little bit better. There's the 3 double pumps that all have the same part name. But what I'm supposed to be doing is identifying which one of these 3 I'm talking about in the, referenced by this schematic. So I'm going to select this one here, and then finally my red tank. So now that the parts are designated, we can see that they have like this reddish kind of highlight around them. And then the ports that we're supposed to be routing to are highlighted in blue as well. So that kind of just gives you a visual cue to say, hey, this is where the routing is supposed to be. And now if I go ahead and set my start on that S1 coordinate system, again, those that will populate with the correct combination of spec size and schedule. So here's where I'm going to get into a little bit of the different functionality that you can use, again, with any of the types of pipe routing, but a little bit more advanced than just specifically choosing, I want this to go 300 units in this direction or whatever. And you can do that by changing this dropdown from 2 coordinates to a long CSIS axis. And then there's a bunch of different options, but the one that I like to use the most is this offset from reference. So now it's asking me for a plane or a coordinate system to be that reference that I'm going to offset from. I want to choose this port 0 coordinate system. And so this is a projection of the x-axis of that port 0 coordinate system. So I'm going to change this to, let's give it something like that. So we can see it's saying 500 units from that coordinate system in this direction is where I want to route that pipe to. So I can hit apply. Now I can swap that to the y-axis, and I can give that a dimension as well. And finally, in the x-axis, I'm going to leave that as a 0 offset and go ahead and say okay. So that's one way to more strategically route your pipes. And finally, now that I'm in a good position here, I can just do a connect. I don't really care how it gets from point A to point B there. I can just connect those.
So Ben, this is Deb. I hate to interrupt, but we are at 12:54 my time. So if we'd like to wrap it up in a couple minutes, I don't know if you want to open it to questions or just have your contact information so people can get back to you if they need to, ask questions.
Yeah, I think there's only really one more thing that I definitely want to show in terms of the schematic driven piping. So I'll do that just very quickly. So again, it's inserting fittings, but a little bit different this time that we have schematics. Once I make a selection, it already knows the first fitting from that schematic file that I have, the XML file that I brought in. It knows that it has a designator of B1. It knows that it's a branch and that branch size should be 32A. So I can go and apply that, and then it automatically knows the next thing is that reducer. If I choose a point, it knows it's supposed to go up to 50A, right? And it's just going to walk us through how these fittings should be placed. So finally, the gate valve, and I'll just say, okay. So there was a little bit more functionality that I was planning to show off, but of course we're running a little bit short on time here. I think that does justice. The rest of the stuff I was going to show is just like other ways that you can place the fittings, kind of similar to how I showed the along CSIS axis, but the general functionality, I think we've fully demonstrated here. So, yeah, I think we can go ahead and open up the floor to questions. And if we don't have any questions, I can shed a little bit more light on, those backend text files, what they look like. I've got an example pulled open, and how we can help you manage this as well.
Just a general question, Ben. So basically, like with the specs, you're basically working like what, say, Schedule 40 or Schedule 80 piping, say maybe PVC or in metal, or essentially using something that's industry defined. Is that correct?
Yeah. Okay. Yes, they are industry defined, but you would have to, there's no way that you can just kind of like click a button and have that all set up. It still has to be set up with these text files that kind of define, this is that HA spec that I was showing earlier. So this is how you set up those rules for what sizes of pipes am I allowed, and what fittings are allowed within this particular spec, what fittings are allowed to be placed on that pipe. So this is what those text files look like. And as Phil mentioned, this is why a lot of people don't like to do this, because it's not only this file, but there's references to the same fitting in 3, 4, 5 different places, different files. And if any one of those is wrong, then spec-driven piping is not going to work. Which brings us to the CAD Active web app, for, to try and help people get over that hurdle of what it takes to actually get into spec-driven piping. We offer, instead of dealing with those text files, you can deal with just this web interface that makes it a lot easier for people. And then we have basically buttons that will go write all of those text files automatically based on your database that you set up here.
Okay, so basically it's like family tables, say for Mill Handbook 5 hardware, but this is for piping.
Yep. Yeah, so you're exactly right. The fittings themselves, the pipes are defined kind of on the fly by Creo, but the fittings do need an actual model too. So this is where we have our CAD model name. And as you can see, based off of the naming format here, these are literally family tables inside of Creo that Spec-Driven is just calling those instances in order to place it in your pipeline.
Cool.
Yeah, and then I guess just to show this off, this is where you can set up your piping specs, and you can define what pipes should be allowable in this spec. And not only that, but what fittings can you use with them as well. So instead of having to go and write all this stuff out manually or using Excel to generate something like this that can be really difficult and messy, you can just define those things in a web application here. And again, so that's actually what I was showing off earlier, our sync piping data tool that allowed me to switch all those config settings really quickly. It also allows me to hit one button here and synchronize all of my piping data from the web application here into all of those files. This is the button that really goes and writes all of those files for you and allows you to utilize them inside of Creo.
Where are you guys based out of? Are you in Wisconsin?
Actually, that's funny you should ask that, because we're located in Denver, but I personally have ties to Wisconsin. I was married in just outside of Green Bay and Pulaski. So while we're not located there, I do frequently visit the Wisconsin area.
You sound like a native, of course.
All right. I know we're at the top of the hour here. We're more than happy to stay on and answer a few questions if anybody has any. But otherwise, thank you everybody for your presence and your attention. And hopefully we'll get an opportunity to continue the conversation.